straight line motion and uniform accelerated motion through qualitative descriptions and the use of scalar and vector quantities. So we've got a graph representation here of both of those, uniform and non-uniform motions. And the best way to describe it is uniform motion is a straight line on a graph, while a curved graph shows non-uniform motion. So uniform linear motion is with constant velocity or zero acceleration, while non-uniform linear motion has variable velocity and non-zero acceleration. Now, an experiment you may have done in class, or one that you've answered it in a question, would be a ticker timer experiment. Now, the ticker timer's tapes show the motion of 4 objects starting from left, moving to right in this example here as shown on the slide. So you can see tape A, B, C, and D have different dots at different positions on that tape. So question A, which tapes indicate the objects are moving with constant speed? And if you look at the B and D, for example, the dots are at equal spaces apart, which show you that they're moving at constant speed. Okay. B, which tapes indicate the objects moving with increasing speed? So this is when the dots are separated. So if you look at A, it shows dots at the beginning are very close together and then they spread out, which is showing you that the object is moving with increasing speed. C, which tapes indicate the objects are moving with decreasing speed? So that's the opposite, where the dots are coming closer together, and that is shown in tape C. So if you look at tape C on the second half, the dots are coming closer together. Now D, which tape shows motion with the least uniform motion? Now if you look at tape C, it's accelerating in the first half and then deaccelerating in the second half, which shows you that there's least uniform compared to tapes A, B, and D. Okay, so some other ways that we can describe uniform and non-uniform motion is looking at scalars and vectors, and this helps us with all physical quantities. So scalars have magnitude, so a size only, so with distance is just meters, while vectors have magnitude plus direction, so displacement will be meters with bearing direction or a northeast southwest. Okay, so if we're adding and subtracting like real numbers, then we're dealing with scalars. If we're looking at vectors, then you need to take into account their direction that they're going in. Okay, so let's have a look at this flow chart here. So all physical quantities, like I just said, are scalar and vector. However, scalar has magnitude only and a vector has magnitude and direction. And this table here has a few examples of each of those. So scalar quantities, like I just mentioned, is distance, speed, and time, while vector quantities are displacement, velocity, and acceleration. Now, another example here of the differences that we've been discussing in class and that we're going to discuss is distance and displacement, which is scalar and vector quantities. Now, distance, like I just mentioned earlier, is scalar and displacement is vector. Now, what is the definitions of distance and displacement? Distance is a measure of how far an object has moved, while displacement is a measure of how far and in what direction from its original starting point. So if we look at this diagram here, distance is the curvature path that the journey was taken, while displacement is from the starting to the finishing line in a straight line with the direction. Let's have a look at this example here. So you can see that there is 3 different paths taken. You've got road 1 at 75 kilometers, road 2, which is 50 kilometers, and road 3, which is 150 kilometers. Now, if you look at this table below, and we're just going to answer this quickly in this video, we'll do the distance traveled first, and then we'll do the displacement. Now, if we're looking at distance traveled, road 1 is taken 75 kilometers, so that's the curvature path. Road 2 has taken 50 kilometers, which is a straight line path, and road 3 is 150 kilometers, which is taking that curved path at the bottom of that diagram. Now, displacement is very different. Displacement is drawing a straight line from its starting and finishing position and giving a direction. So displacement would be 50 kilometers east for road 1, 50 kilometers east for road 2, and 50 kilometers east for road 3, which is exactly the same answer for each of those. Now, that's a straight line from its starting position to its finishing position.